Hey Fox, welcome. So today let's discuss LeetCode 1296. Divide array in sets of k consecutive numbers. The question is given an array of integer nums. So the array contains an integer and a positive integer k. Find whether it's possible to divide this array into sets of k consecutive numbers. Okay. Return true if it is possible. Otherwise return false. So here in the first example, you are given an array and your k has to be 4, right? So you want subarrays of size 4 each, and each of those subarrays should contain the integers in a consecutive order. So this array has a size of 8, right? And 8 is divisible by 4. So you can end up with two subarrays. So this is the first check which you can apply, right? That if your array maybe had been of size 9 or not a multiple of 4 in this case, then you could never have obtained an array. Okay, cool. So once you're able to apply that check, then let's try to understand like how would we have gotten the answer. So the example here is something like 1, 2, 3, uh, 3, 4, 4, and a 5 and a 6, right? And your k is 4. So basically, the way to get the subarray of size 4 is to try to start building the array of size 4 greedily, right? So what you do is that you start off with 1. So right now your subarray is of size 1, right? And then you try to take 2 also, and then you try to take 3 also, and finally you want another element because you want to complete your array of size 4, but you can't take this 3 because it's essentially duplicate in nature, right? So let's forget this for now, and then maybe we are taking a 4. So this is the first subarray which we obtain, and then the second subarray which we can obtain for this problem is like you take this 3 and then 4, 5, 6. So before we read about this example, let's talk about a simpler case. So a case which I think we can make is that suppose your array contain is distinct elements. Okay, so suppose your array contains distinct elements. So how will you basically try to check? How will you try to obtain the distinct subarrays of size k in this case? So suppose your array is something like 4, 5, 6, 7, 8, 9, and 10. Okay, so and maybe you are trying to find a subarray of size 4. So in this case, basically what you will do is you can guarantee that since the array is sorted, and since you are looking for a consecutive element, so basically you can build a sort of windowing approach into this. So first you take a window of size 4, right? And you check whether all the elements inside this are continuous in nature or not, right? And once you can build this window and you can check that the elements inside it are continuous, then you can again start off and take the next four elements, right? And then in the end what will happen is that you will only be left over with two elements, and those two elements won't be able to give you a subarray of size 4, right? So in this case, if the array is distinct, containing distinct elements, so but you need to actually sort the array, right? So the sorting will take n log n time, and then once you have achieved the sorting, then the problem becomes trivial, right? That you are partitioning this into k parts, and for each of the part you are checking whether the elements inside it are continuous or not. So it's essentially a order of n time operation, right? So it seems that this approach will work if the elements which are given to you are distinct, right? But let's talk about the original case which was given to us, which is this case, right? So here the problem comes because the elements are starting to repeat. So here, as you can see that so when I am trying to build a window of size 4, so I was able to build it till 1, 2, 3, but then another 3 came. So the answer of the first subarray was 1, 2, 3, 4, right? But to get this 4, I had to disconnect this red colored line which I'm trying to make. So So the problem is that if I try to find subarrays of consecutive elements by a sliding window approach, it is gonna fail in case the elements start to become duplicates, right? When the duplicate thing starts to go out of the picture, when the sliding window approach starts to go out of the picture, at that moment, if we want a better solution, we need some sort of hashing approach, right? So when the elements were distinct, right, the solution was essentially order n log n for sorting and order of n time for checking whether the windows which you made were consecutive or not. But so now we want to build something for the duplicate case, which can also run in a linear time, right? We can't get away with the time of sorting. Okay, let's try to do that. So in this case, the idea is very simple, right? That if your sliding window fails, right? If your sliding window fails, then what you need is a sort of method which can still run in a linear time, right? So, so a way to do that is through a hashing method. And what we can do here is that suppose let's look at the same example. Okay, one, two, three, three, and four, four, five, six. So what do we need in order so if we are given a k of 4, right? So what do we need in order to find a subarray? So suppose we are given the minimum element inside a subarray. So let's suppose that I start off with an integer called 1. Okay, so if I take an integer called 1 and then I try to form a subarray of size 4 from it, so it will be 1, 2, 3, and 4, right? So what I can do is I can automatically start to generate the first subarray of size 4 greedily from this from this array, right? So if I I first look at the lowest element and then I try to greedily generate a subarray of size 4. So in this case, it's gonna be the first subarray will be 1, 2, 3, 4, right? So what I can do is, since I've already used up these elements, I can essentially start cutting off my array, right? So the new array which is left is 3, 4, 5, 6, right? And then I can start off from the lowest element again and try to generate try to generate a 4 size array again and keep on canceling the elements until my array becomes empty, right? So it appears that this approach will work. Uh, let's try to validate it from some other perspective. So let's have a look at this example. Okay, so the example, let's have a look at this example. Because it's a bit simpler to understand. The array which is given to you is essentially a 3, 2, 2, 1, and a 1, right? And your k is given to be the 3. So you have to basically try to build subarrays of size 3 out of it. So the first step to do this is to sort the array. The reason we are sorting is because you want the ability to generate the subarray in a linear time. If I had kept it like this, one of the options would have been that I choose 3 elements at random. So since it contains 6 elements, so I will take pairs of 3 elements first, and then I will check whether they are consecutive in nature or not. But the elements won't be consecutive or may not be consecutive. So the number of checks which we have to do will actually be exponential. So that's why we are trying to sort. So once we are sorting in this array, we will start querying the first smallest element. So it's 1, right? And we want to generate a subarray of size 3. Uh, the the element which can be there is basically 1, 2, 3, right? So if you start off with a 1 and try to build a subarray of size 3, I automatically cross these numbers off, right? And then again here I end up with a subarray of size 1, 2, 3, because I was able to generate one subarray here. So if you're given this 1, 2, 3, so from this again you can choose the minimum element and then you can end up with the other element, right? You can end up with another subarray, and when you cancel out, then this subarray will automatically get reduced from a size 6 to size 3 to finally uh, empty set, right? So that is the point. So the logic becomes something like this, that you try to sort your array, and then you choose the minimum element, and you start to greedily form the numbers out of it, and then try to form a subarray of size k, and finally try to cross off the elements, and then you find a new subarray, and this process will continue until the array gets exhausted. But what does the method of crossing off the things in an array look like? So if I take the same example, okay, so it's like 1 1 2 2 3 3. So suppose I wanted to generate a subarray of size k. So I would have started off with 1, right? And then I would have gotten so if I started off with 1 and tried to build a subarray of size 3, so it would have been a 1 2 and 3, right? So when I am actually trying to cross it off, basically I want to delete a 1, delete a 2, and delete a 3. So each time I am trying to basically uh, each time I'm basically trying to traverse over the entire subarray till I find these integers, right? So it's gonna take me order of n time to traverse this array to basically cross the elements off, and then to basically form the newer subarrays. So earlier my array size was n, right? And now once I have crossed over k elements, so basically n minus k elements are gonna remain, and finally since n minus k elements are gonna remain, so yeah so and yeah so basically when you are trying to then from this n minus k elements, you will again try to pick up k elements out of it, right? So basically, if you can see that you are trying to uh, extract a set of size k out of n elements every time. So and each of the times you are taking n operations, right? So your time complexity will basically become n over n minus k, which is n squared minus nk, which is order of n squared in this case. So although the method of sorting and then applying a greedy approach works, right? But when you are trying to actually locate the elements inside the array, the things start becoming more complex. So what should be the ideal way? So we are still aiming for a order of n time approach, right? And we want a order of n time approach, right? And order of n log n is the time complexity which we apply to sort the array. But is there a better method instead of just getting restricted to order of n squared? So let's try to return to this example, which is 3 3 2 2 1 1. Okay. So the algorithm should proceed like this, right? We already agreed that we need to sort the array. So since we are already sorting the array, so this is the type of thing which we are getting, right? uh, and then instead of trying to basically cut off the elements from this array, we can basically do something better than this. Yeah, just a moment. I think okay. So the way in which we can proceed through this is like this, that let's start to basically build a hash map of frequencies of each of the elements in the array. Okay, so here the number of ones is 2, the number of twos are 2, and number of threes are 2, right? So uh, so then when you are starting to build a subarray, start by basically counting the smallest element. So in this case, whatever subarrays one will start forming, uh, those subarrays will contain one, right? It will contain only a single one. And then so it should start from 1, right? And it should then be of length k. So in this case, the k is 3, right? So if the subarray starts from 1, then it should contain 3 elements, right? So what you can do is you can start iterating through this map, and you can start decrementing the count every time, right? So it's like this right now, that so right now, first what you want is to basically a subarray will start off with a 1, right? So and it should be of length 3. So you see that right now all the ones are free. You have not used any one to form a subarray. So you start from here and you go on till 3 elements and you try to basically form a subarray out of it. So uh, you when you take a single one, you decrement this to 1, and then you come to 2, you decrement it to 1, and you come to 3, you decrement it to 1, right? So by now you have essentially made a subarray called 1 2 3, right? And then you again start off with this 1, right? And decrement this by certain amount, and put these elements inside another subarray. So you will essentially continue this process until you can run out of the elements in the hash map. Okay, so to illustrate this approach, let's try to take another example. So let's say that suppose your array had been 8, 10, and 8, 9, 10, and a 12. Okay, so so in this case, the count of 8 is 1, the count of 9 is 1, count of 10 is 1, count of 12 is 1. And suppose you are asked to create subarrays of size 2. Okay, so in this case, what you will do is you will start off with k, right? Start off with 8. So you will look at this 8 and you will say, yeah, there is one 8 which is free. So a valid subarray will, if it starts from 8, and the elements in that subarray have to be continuous. So it should be like 8 or 8 9, right? So I will start off from 8, and I will decrement the count of 8, right? And then I will come to 9 and I will see that 9, okay, 1. So 1 9 is available in the array. So I can decrement this count, right? So and this is one of the valid arrays. Okay, then let's come to 10. So when we start coming over to 10, at that moment we say that okay, 10 is greater than 1, right? So 10 can be start of a valid subarray. So we will start off with 10, and the next element should be 11, right? So we check, does this hash map contain a 11? No, it doesn't, right? So that's why at that moment we have to return a false. So this is the approach which we are trying to do. So basically take a build a frequency map of the elements, and then look at a element and try to think whether this element will form the starting point of a subarray or not. And if it actually forms the starting point, then it's fine. You go on to build the k elements as long as they exist in the hash map and the values are greater than a particular number, then it's fine, right? But in this case, like if you started building an array from 10, and you want it to be of size 2, then as long as you see size 11 thing, it's not present in the hash, so you're not gonna be good. So let's try to code this up now. Okay, uh, okay, so cool. So let me try run. What should be the first thing? The first thing is that we want to basically build a hash map which contains these elements, right? So we will do collections dot counter of nums, right? So it will basically contain the counts of all the elements, right? And then what you want is to basically sort your array. And once your array is sorted, right, so you will start looking at individual elements in this array. Okay, and when you look at a particular element, then this element might form the start of a valid subarray, right? Valid subarray of size k. So from this element you will basically try to take this element, and you will start to build. So first you will check, right, whether this, it's like you are trying to build a 1 2 3, right? So if you are given an array like 1 2 3, and you are trying to basically build a subarray of size 3 from this, so you will start off from 1, right? And you will look over 3 of the elements in its vicinity. So at that point the frequency of 1 will be 1, right? So So if so here you have to actually apply a if loop, right? So if num of so if c of num, right, is greater than 0, in that case, what you will do is, just a moment. Yeah, instant, you don't actually need this, right? So for so you can start off from a number. uh, okay, so hmm. So what should it be? So you are basically going through each number in the array, and uh, you want the subarray to be of size k, right? So okay, so you will basically check, right, whether that number's frequency in the map is greater than 0 or not. So so if num of so if c of num is greater than 0, right, then it's fine. So you can start off from this element, right? So for I in range of num to num plus k. So in this case, what you can do is you can start to take the element if you want. So what you can do is that you can decrement the value by 1, right? And if the number is actually not present in the counter, so if ci is basically uh, less than 0, right, so in that case you have to return a false, right? Else all things are fine, you can return a true. So so yeah, so that will be the case. So for this example here, right, so if you take this example, uh, so here, if I try to build a counter, it will contain a single one, right? And it will contain a two. It will contain two threes, right? And it will contain two fours, and it will contain a five, and it will contain a six, right? So the first thing which we are trying to do is that we are taking the first number inside this. So we are gonna be present here, right? So and we want our k is essentially 4. So we are trying to build four integers. So c num, so c of 1, right? So 1 is greater than 0. So what you are doing is you make this element 0, right? And you make this element 0, you make this 1, and you make this 1. So one of the subarrays which you end up is be will be 1, 2, 3, and 4, right? Uh, okay, and then you come to 2. So your index will basically traverse to 2, and then at that moment, your CI, yeah. So in that moment, your C of 2 will be 0, right? So it means that you have already taken that 2, so you don't need to take it again. So you can essentially continue inside the loop, right? And finally you can start looking at this 3. So if you look at this 3, so one of the threes is left, right? So at that moment what you can do is you can start off another subarray of size 4 from 3. So you will make this a 0, you will make this a 0, you will make all of these as zeros, and finally you will end up with a subarray of size k, right? Yeah, so I think this code should work. Let's try to run it. Yeah, so cool. So as you can see, it passed, and it's faster than 70% of the solution. So the next case which remains is that can we optimize it further? Okay, so let's try to think on that. Okay, so one simpler example for this is that let's suppose that what your array contains is only a permutation of 1 2 3. Okay, so it's having 1 2 3, maybe some threes here, okay, maybe some twos here, and uh, some ones here, okay. And you are asked to basically form subarrays of size 3 from this. So you can see that for this array the size is 9, right? So the first step will be to sort it, right? So when you're trying to sort it, so basically the answer has to be 3 1 2 3s, right? This is the answer which we are trying to build. So if you look at the counts here, right? So there are 3 1s, 3 2s, and 3 3s. So the first time we take an integer, so whenever we take one, right, so we know that there are 3 1s, so these 3 1s should basically start off new subarrays of itself. So why don't we start off 3 subarrays of all the size 1, and we put it as a 0 here. So when we come to 2, right, the two, so the since all the numbers should be consecutive, so when you're coming to 2, then the 2 should also basically stick off towards the end of all these numbers, right? So that's why you can directly decrement 3 out of it, and similarly for this 3 you can decrement 3 out of it. So the idea is that when you're choosing the number first, so here in this case it was a 1, so it had a 3 value, right? So you need the ability to basically subtract 3 from all the subsequent elements in the future. So in that way, it will help you to reduce the number of times you are actually invoking the loop. Because right now what we are doing is we are decrementing this by 1, and then we are making a subarray of size 1 2 3, and then we are again decrementing by 1, right? And we are making a subarray of size 1, right? Again we are getting a 1 2 3, and then we are basically decrementing again till all the elements becomes 0, right? So essentially you are decrementing 9 times to form 3 subarrays. So uh, what I'm trying to say is that once you look at the first integer, which is a 3 in this case, you directly know that these 3 1s need to start up 3 separate arrays, subarrays in the future. So why not try to decrement the 3 directly from the 2? So so that is one optimization which we can make. So in this case, right, so in this question, like what you can do is basically instead of decrementing 1, right, so you can store the occurrences of CI element, right? And then you can basically try to decrement the CI by the same amount, right? So that should actually speed up your code a lot, because it's essentially just a moment, what happened? Oh yeah, sorry, this should be now, right? Yeah. So this should essentially speed up your code, and you can see that the runtime has actually decreased from 416 milliseconds to 380 milliseconds. So yeah, so this is one of the optimizations you could apply. So overall, this question is bit on the easier side, and it will help you to basically understand the concept that when you are given an array, you can actually partition it, and since you are only asked for a consecutive number, right? So you should try to build your array by assuming that you're given a smallest number in the subarray, and you have to greedily add 1 to the number and form a subarray of size k, right? And each of the elements should be in fact present in the original array. So we also saw that when you are actually trying to search for the elements inside the original subarray, it will give you order of n squared solution. But to get order of n solution, you actually need to trade off your time with some sort of space. So here, that's why we had to actually build a frequency counter. Yeah. So thanks.